The launch of the James Webb Space Telescope in December 2021 marked a new era in astronomy. This advanced telescope is allowing scientists to explore parts of space and time never before seen with such clarity. In particular, the JWST is providing an unprecedented view into the early days of the universe, just a few 100 million years after the Big Bang. These observations are challenging many long-held theories about the evolution of the cosmos in its infancy. One of the most astounding findings from the JWST so far is the discovery of early galaxies that are surprisingly massive and mature. Based on existing models of galaxy formation, scientists expected to see small, simple galaxies in the first billion years of cosmic history. But the JWST revealed some galaxies dating back 13.1 billion years that are as developed as present-day galaxies like our Milky Way. One ancient galaxy discovered by the telescope has a stellar mass 100 billion times greater than our Sun. For comparison, the Milky Way is estimated to have a stellar mass around 60 billion suns. The maturity and large size of these primordial galaxies upends the prevailing idea that galaxies start small and gradually grow bigger over time. Now it seems that at least some galaxies in the early universe formed much more quickly and were more well-developed than previously thought possible. This suggests fundamental processes in the early cosmos that allowed galaxies to form and evolve at a rapid rate. Studying the light from ancient galaxies can also reveal their redshift, which indicates how fast they are moving away from us. The higher the redshift, the farther back in time we are looking. The most distant galaxy observed by the JWST so far has a redshift of 13.2, meaning we are seeing it as it was just 400 million years after the Big Bang. For comparison, the most distant galaxy spotted by the Hubble Space Telescope had a redshift of 11. The JWST's power to see farther back in time and space is allowing scientists to probe cosmic environments never before accessible. The JWST achieves this due to its specialized infrared vision. While past telescopes like Hubble detected ultraviolet and visible light, the JWST was designed to see infrared wavelengths. This capability allows it to pick up the faint glow from the oldest, most distant stars and galaxies. The expansion of space causes light from these ancient objects to be stretched into infrared wavelengths. So the JWST can effectively glimpse the first light in the universe. One of the telescope's key projects for studying the early universe is an initiative called JWST Advanced Deep Extragalactic Survey. Over the course of a month, JADES is compiling an unprecedentedly detailed portrait of the Hubble Ultra Deep Field, the deepest view of the universe ever taken. This tiny region of space contains thousands of galaxies at different epochs of cosmic history. By combining the JWST's infrared imaging power with its spectroscopic capabilities, JADES is able to analyze the composition and other physical attributes of these galaxies. Redshift measurements from the spectroscopic data allow precise calculations of their distances. JADES and other JWST surveys are also searching these deep cosmic fields for the earliest supermassive black holes. Based on current models, these gravitational monsters were not expected to have formed so soon after the Big Bang. But some recently observed ancient galaxies appear to contain supermassive black holes in their cores. This suggests that black holes developed much faster and earlier than thought, which has huge implications for understanding galaxy evolution. The groundbreaking observations from the JWST's first 6 months already demonstrate how this telescope is rewriting the history of the early universe. Key discoveries like the unexpectedly massive infant galaxies and record-breaking ancient objects observed by JADES show there are major gaps in our cosmological models. As the JWST continues scrutinizing the deep cosmos over its planned 10 to 20-year mission, we can expect many more surprises that transform our knowledge about the origins of galaxies, stars, and black holes. The farther back in time the JWST enables us to look, the closer we come to witnessing the first light emerging after the Big Bang birth of the universe 13.8 billion years ago. While the JWST will likely never see all the way back to the Big Bang itself due to the opaque plasma fog of the early universe, it takes us closer than we have ever been before. The telescope's visionary technology is unveiling the formative chapters of cosmic history and fulfilling one of humanity's most epic adventures, reading the creation story of our universe.